Hi Flashes, so today I'm going to be going through your guys' study guide with you. So first thing it says, identify whether each pair of shapes, that should be shapes, are similar or congruent. So if you guys remember, similar means that they are the same shape but different sizes, and then congruent means that they are the same shape, same size. Okay, so look at number 1. Notice that we have same shape and same size, so that would be congruent. Number 2, we have same shape but different sizes, so that would be similar. And then number 3, we have same shape, same size, so that would also be congruent. Remember, you guys can pause this video at any time, but I'm just going to keep on going. Number 4 through 6, identify the transformation performed on each pair of shapes. Give the details of the transformation. So, if you notice here, we have 2 images. So here's the original image, and then here is the transform image. And if you notice, it looks like a mirrored image because here was C, and then C ended up over here. Here was B, B ended up over here, and then same thing with A. So if you have that mirrored image, it is a reflection. And then you have to be specific on what kind of reflection. So did it reflect over the y-axis or did it reflect over the x-axis? Well, here's your x, here's your y, so if we flipped it from here to here, that means that we reflected over the y-axis. Okay, number 5, notice how we had this image as the original image, and then it moved over here to get this image, because if you notice, all of our order pairs, the A, B, C, stayed in the same spots on the triangle, it just shifted over. So that means that this is a translation. And then you just need to tell us how far did it move. So if you notice, it didn't move up or down, it just moved to the right. So let's count how many times it moved over. 1, 2, 3, 4, 5, 6, 7, and I'm just going to check another point. 1, 2, 3, 4, 5, 6, 7. Yep, so it moved to the right 7. So you would just write translation 7 units right. Alright, and then this last one, so here's our original figure, and then it transformed to up here. So notice how it looks like it rotated, and notice the direction that it went in, because C stayed the same, so that will be our center of rotation there. And then B rotated this way, and A rotated this way as well. So we do know that it's a rotation. And then notice the way that it rotated. So think of a clock. Clockwise is going to the right. So it did rotate to the right, which means that it would be a 90-degree clockwise rotation. All right. Number 7, which transformation or transformations result in congruent figures? So remember, congruent means that we're going to have the same shape, same size. So all of the transformations that we get the same shape and the same size are reflection, rotation, and translation. The only one that's not congruent would be dilation. Dilation would be our similar shape. Because remember, with dilations, we're either making a figure bigger or we're making a figure smaller. So they would not be the same shape, or sorry, they would not be the same size. So dilation would be similar, but all these rest are congruent because we get the same shape and same size. Okay? All right, number 8, determine the relationship between the 2 figures. So our answer choices are congruent, similar, neither, or both. So it says ABC is the original figure, and then RQP is the transformed figure. So when we say ABC, notice how these go in order. So A is going to be congruent to R, B is going to be congruent to Q, and C is going to be congruent to P, okay? So notice that we do have the same triangles, because if I were to count my sides, this has side length of 2, AC has side length of 2, so does RQ and RP. So I know for sure that I have the same shape, and I do know for sure now that I have the same size, because I know that my sides are all 2's. So this means that we are going to have congruent figures because it's the same shape and the same size. All right, moving on to number 9. So identify the transformation performed on the figure to get its image. Triangle ABC is the original, and triangle PRQ is the image. So once again, look at your answer choices. So we're trying to figure out what transformation is performed, and you just have to think of the different situations. So if I pick one point, so let's say I pick point A, I am trying to figure out how can I get point A over here to point P within one transformation. So let's go through the answer choices. So dilation. If I have a dilation, that means I'm making my figure bigger or smaller. But if you notice, these are both the same shape. So I know for sure it's not dilation. Reflection, we can only reflect over the x-axis or the y-axis, which means that my figure would be in one of these quadrants, but our figure's over here in the opposite quadrant, so it can't be a reflection. Rotation, if I were to rotate A 180 degrees, and remember, it doesn't have to be over the origin. It could be a point over here, it could be a point over here. So I can rotate this to get this figure over here to this side. So that is an option, so I'm going to leave C open, but I do want to make sure translation is not one of them. So translation means that we're just moving this figure. But if you notice, if I were to move this figure from quadrant 1 to quadrant 3, I need my A to be down here somewhere. Okay, so I can get the same sided of the shape, but if you notice, it kind of flip-flops. So it can't be translation. So the only one that makes sense here is a rotation. Okay. Now, if you rotate it about the origin, obviously our points are not going to end up where they're supposed to be at. But once again, you don't always have to rotate about the origin. All right, number 10, triangle TUV is plotted on a coordinate plane. Find the coordinates of point V if the triangle is reflected over the x-axis and then rotated 180 degrees. So there's a couple different ways that you guys can do this. You can perform this on the coordinate plane, or you can just use the rules and write out the coordinate for point V after all these transformations happen. So that's what I'm going to do. So we're looking at point V. So if you notice, point V is at order pair 1, 3. And then let's just perform the rule. So the first thing that happens is it's reflected over the x-axis. So if I reflect over the x-axis, that means that I multiply my y value by -1. So 3 times -1 is -3. So when I reflect over the x-axis, I now get 1, -3, where my V ends up at. Okay. Then it says rotate 180 degrees, so that rule is I multiply my x and my y value by -1. So multiply 1 by -1, and that's -1, and then multiply -3 times -1, and that's +3. So 1, -3 was after I reflected, and -1, 3 is after I rotated. Okay, so -1, 3 is answer C. All right, moving on to 11. So same triangle, but now we're going to use the coordinates of point U, and we are going to dilate by a scale factor of 2 and then translate 3 units down. So again, you could do this on the coordinate plane by drawing it, or you can just use the coordinates of point U to perform the transformations by the rules. So point U is at 2, 1. And the first transformation is to dilate by a scale factor of 2. So if you're dilating by a scale factor of 2, that means that you are enlarging your figure by making it bigger, which means that we are going to multiply our numbers by that dilation of 2. Okay? So when I do that, 2 times 2 is 4, and then 1 times 2 is 2. So my point U is now at 4, 2. But then the second thing is that they want us to translate 3 units down. So if I translate 3 units down, I can show this over here. So U is right here now. If I translate 3 units down, I'm now going to end up at this point. And remember, if you're going down, that's talking about the y-axis, and then going down is going towards the negatives. So this rule is that you're going to take your y minus 3. So if I take 2 minus 3, I get -1, and from my picture, I do end up at -1 on my y-axis, so I know I did that correctly. So our end value is going to be 4, -1, which is a D. All right, moving on to number 12. So select all the correct sequences of transformations that occur to get pentagon ABCDE to pentagon A double prime B double prime C double prime D double prime and E double prime. So my advice to you guys is to pick one point. Okay, so pick any point on the original figure. So let's say I pick A, and then I'm trying to figure out how can I get A from here to here, and then I can use these different transformations that they give me to see if I can get there. Okay, so again, there's a couple different ways that you guys can do this. You can perform all of these on the coordinate plane, but that might get kind of confusing. So you may have to use the order pairs to figure that out. Okay, so let's say I do the first one here. So point A is at -4, 5. And the first thing that it says is to rotate 180 degrees. So the rule is if you rotate 180 degrees, you multiply both of your values by -1. So -4 times -1 is +4, and 5 times -1 is -5. Then it tells us to reflect over the y-axis. So when you reflect over the y-axis, what you need to do is multiply your x value by -1. So 4 times -1 is -4, and then your y value stays the same. So let's see if A ended up at -4, -5. -4, -5. There's nothing over here, so I know for sure that A is not an option. Okay? So let's try B. Rotate 90 degree clockwise. So again, -4, 5 is where A starts at. If you rotate 90 degree clockwise, you multiply your x value by -1, and then you flip-flop your values. Okay, so -4 times -1 is +4, and then when I flip-flop my values, I get 5, 4. All right, and then the second thing says that I need to translate 7 units down. So that is talking about my y-axis, because going up and down is the y-axis. And then if I'm going down, I'm going towards my negatives, so I'm going to be subtracting my y value -7. So 4 is my y value, so 4 minus 7 is -3. So I'm going to end up at 5, -3. So let's see if my A value is there. 5, -3. Nope, there's nothing there, so it can't be B. Moving on to C, so now I'm going to do this down here. So A is still at -4, 5. First thing, it says to reflect over the x-axis. So if you reflect over the x-axis, that means you're going to multiply your y value by -1. So 5 times -1 is -5. Then it says to translate 8 units to the right and 2 units down. So translating 8 units to the right is talking about the x-axis. And since you're going towards the right, you're going towards your positive value. So you want to add 8 to x. And then 2 units down is your y-axis, and you're heading towards the negative. So you want to subtract 2. Okay. So if I do that to -4, -5, -4 plus 8 is +4. And then -5 minus 2 is -7. So let's see if A is at 4, -7. 4, -7. Bingo, there it is. Okay, now let's just double check to make sure that D is not 1 as well, because it does say select all the correct sequences. And you do sometimes want to make sure. So just because A ends up over here does not mean that all of these other points are also going to end up over here. So you could keep choosing all the points just to make sure they do all end up over here. But if you notice that they will end up over there. Okay. All right. Last one, reflect over the y-axis. So when I reflect over the y-axis, I multiply my x value by -1. So that would give me 4, 5. And then dilation, scale factor of 2, that means that my shape is going to get bigger, but if you notice, my shapes are the same size. So I don't even have to write this out because I know for sure that this is not a dilation. So my answer is C. All right, number 13, identify the transformation performed on the figure. So notice how we have different shapes, or sorry, we have the same shape but different sizes. So if it's different sizes, then we know for sure that this transformation is a dilation. All right, triangle TUV is plotted on a coordinate plane. Find the coordinates of point T if the triangle is rotated 90-degree clockwise. So notice that T is right here at 0, 0. And if we rotate it 90 degrees clockwise, we're rotating it about the origin. So this is actually our center point, which means that our T value is not going to move at all. And you can even test it out if you wanted to. So T is at 0, 0. 90-degree clockwise means that we're multiplying our x value by -1 and then flip-flopping your y and your x. But if you multiply x by -1, so 0 times -1 is 0, flip-flop your two numbers, you still get 0, 0. So like I said, T is our center of rotation, so it's not going to move because we're rotating around that point. Okay. All right. Number 15. So same triangle. Now we are going to use the point V and dilate it by a scale factor of 2. So first, if I have point V, it's at coordinate 1, 3. And dilating by a scale factor of 2 means that we are going to enlarge our figure, which means that we should multiply our numbers by 2. And when we do that, 1 times 2 is 2, 3 times 2 is 6. So our coordinate V is going to end up at 2, 6. All right. Number 16, describe the sequence of transformations that occur to get from pentagon A, B, C, D, E to pentagon A, double prime, B, double prime, C, double prime, D, double prime, and E, double prime. So again, just like I did on that other example, you could use these transformations to do it on the coordinate plane, but that could get kind of confusing. So once again, just pick one point. I always try to pick a point that is not on the X or the Y axis. I try to pick one that's in an actual quadrant. Sorry, I couldn't think of the word. So let's say I pick C. Okay, so C is at point 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. And then I am going to figure out which one of these gets from C to C prime, C double prime. All right, so first one, reflection over the y-axis. So reflecting over the y means that I'm going to multiply my x value by -1. So 9 times -1 is -9. and then 2 is going to stay the same. And then translate 8 units down, so that means that I'm going to take my y value and subtract 8 from it. So 2 minus 8 gives me -6. Alright, so if you were to see over here, so I'm trying to figure out if C double prime is at -9, -6. It is at -9, but it's not at -6. So I know for sure it's not A. So let's try B. So reflection over the x-axis, which means that you're going to multiply your y value by -1. So that would be 9, -2. And then reflection over the y-axis, so now I'm going to multiply my x value by -1. So that will be -9, -2. So if you notice, C double prime is at -9, -2. But again, you can always check another point as well just to make sure. So let's try B. So B is at 1, 2, 3, 4, 5, 7, 1, 2, 3, 7, 4 it looks like. So if I were to do the same transformation, reflect over the x, so multiply your y by -1. And then reflect over the y, so multiply your x by -1. You get -7, -4, and if you look, B double prime is at -7, -4 down here. Okay, and again, you can keep doing that to all of your other numbers as well, but you will notice that B is going to be our answer. Okay, and again, you can always go through the other ones as well just to make sure, but for time purposes, B is going to be our answer. Okay. All right, number 17, plot the points for quadrilateral ABCD on the coordinate plane, and then dilate the quadrilateral by a square factor of 1/2. Plot the dilation on the coordinate plane, state the vertices of the image. Okay, so let's first start with the original figure. So we have A is at -6, -4, and please be sure that you guys label these points. Okay, it's very essential that you guys do that. B is at -2, 2. C is at 4, 4. And D is at 4, -2. And I'm going to try my best to draw a straight line. I know I have a ruler, but it's okay. There we go. That's pretty good. Alright, so when we dilate by a scale factor of 1/2, that means that we're making this this figure smaller. So that means that we need to divide all of our numbers by 2. So I am going to rewrite these values down here to make it easier to see what I'm going to do. So this was A. Okay, so just like I said, dilating by a scale factor of 1/2 means that I am going to divide both of my numbers by 2. So I'm just going to show you that I'm doing that. So if I were to take -6 divided by 2, that's -3. And then -4 divided by 2 is -2. -2 divided by 2 is -1. 2 divided by 2 is 1. 4 divided by 2 is 2. And again, 4 divided by 2 is 2. And 4 divided by 2 is 2. And -2 divided by 2 is -1. Okay. So these are our new coordinates, and I need to make sure that I plot these on my coordinate plane. So A prime is at -3, -2, and once again, make sure you guys are labeling that point as A prime. Okay. B prime is at -1, 1. C prime is at 2, 2. And D prime is at 2, -1. So a couple things to know that you did this correctly. Okay, we do know that dilations are still going to have the same shape. So if you notice, my dilation did have the same shape, just a different size. And then since I did do a scale factor of 1/2, I know for sure that my figure is shrinking. So when you shrink your figure, it's obviously going to be smaller than the original figure. So there's just a couple of different indicators to know that you did this problem correctly. All right, moving on to the last page. So number 18, plot the points for triangle ABC with vertices A 4, 1, B -3, 1, and C 2, 5 on the coordinate plane. Reflect the figure over the x-axis and translate the image 2 units right and 3 units up. Plot the transformation on the coordinate plane and then state the vertices of the image. Okay, so let's go ahead and draw the original triangle. So A is at 4, 1, B is at -3, 1, and C is at 2, 5. All right, so first thing that we need to do is reflect our figure over the x-axis. So if you guys are pretty good at doing this, if you're reflecting over the x-axis, you just need to move your points however many units are away from the x-axis. So like A is 1 unit away, so that means A prime will be down here. Same thing with B prime. And then C is 5 units away from the x-axis, so if you flip-flop that, it's still going to be 5 units away, okay? But if you guys haven't noticed that yet, you can still have all of your ordered pairs that we have and just perform the rule. So the rule is, if you're reflecting over the x-axis, you multiply your y value by -1. So this will become 4, -1, -3, -1, and 2, -5. So these will be A prime, B prime, and C prime. So let's go ahead and plot those. So A prime, B prime, and C prime. All right, and then we still have one transformation to perform, and that is translating the image 2 units right and 3 units up. So remember, when you're translating to the right, that means that you are taking your x value plus 2, because x-axis is on the horizontal line and going to the right is towards the positives. And then going 3 units up is talking about your y-axis, and you're going towards the positives as well if you're going upward. Okay, so I'm just going to perform this rule. So 4 plus 2 is 6, and -1 plus 2, or sorry, plus 3 is 2. So A double prime, so I should really just be writing these down here, is at 6, 2. B double prime, -3 plus 2 is -1. And -1 plus 3 is 2. And then C double prime, 2 plus 2 is 4, and -5 plus 3 is -2. All right, and you could also take your A prime figure and just perform it on the coordinate plane as well. So going 2 units right, 1, 2, 3 units up, 1, 2, 3. I stopped at 6, 2, and if you notice, that's what I already had for A double prime. Okay, so you could do that for all of your points here if you really wanted to, and then just don't forget to label them. All right, and those are your figures. Again, pause the video if you guys need to write that down, okay? All right, number 19, find the coordinates of the image of triangle ABC when it's reflected over the y-axis and translated 1 unit to the right and 2 units down. Draw the 2 transformations on the given coordinate plane. All right, so reflecting over the y-axis, so this is our y-axis. Again, kind of like I talked about in another example, if you're reflecting over the y-axis, your values will just be how far away it is it from the y axis. So like B is 1, 2, 3, 4, 5 units away from Y. So if I reflect it over the Y, it's also going to be 5 units away from the Y. So that will be B prime. And then notice how A and C are on the Y-axis, so it's not going to move since we're reflecting over the Y, so it's still going to stay in the same spot. But once again, you can take all of your values or the order pairs. So A is at 0, 1, B is at 5, 1, and C is at 0, 4. And if you perform the rule, which is multiplying your x values by -1, well, 0 times -1 is 0, 5 times -1 is -5, and 0 times -1 is 0. So you'll notice that A and C still end up in the same spot. Okay? All right, and then the double transformation. Second step is moving 1 unit right and 2 units down. So moving 1 unit right means we're going to take our x plus 1, and moving 2 units down means we're going to take our y minus 2. Okay? So if I do that, 0, my x value is 0 plus 1 is 1, and then my y value, 1 minus 2 is -1. -5 plus 1 is -4, and 1 minus 2 is -1. And 0 plus 1 is 1, and 4 minus 2 is 2. And then once again, just make sure when you guys are plotting these that you guys are labeling and making sure that they are in the correct spot. And those are our primes and double primes. All right, last question. Describe the transformation that happened. So number 20, notice that we started with 2, 3, and then we went up to 4, 6. So as soon as I see that I have different values than what I started with, I know right away that this is going to be a dilation. And if you notice, 2 went to 4, so that means that it multiplied by 2, and then same thing as 3 went to 6, it multiplied by 2. So once again, I know that that's going to be a dilation. Alright, and then -4, 5 went to 5, 4, so I ended up with the same numbers, okay, but notice that my values did flip-flop. So I know for sure that this is going to be a rotation because that's the only transformation where you flip-flop your values. And then if I wanted to be more specific, notice how we multiplied our x value by -1 because it went from a negative to a positive. So I know that's going to be a 90-degree rotation, clockwise rotation. But you just had to put what the transformation was, okay? Alright, so this is your guys' study guide. If you guys have any questions, make sure you ask your teacher. But I hope you guys do well on your test.